Hello my friends, welcome back. What I have for you today is a GPS module and an LCD display connected to Arduino. So we're getting closer to the autonomous vehicle, but we're moving slowly, but surely we will get to the autonomous vehicle at some point. And this is getting us closer because a GPS is very useful, because we can use the GPS to determine the vehicle's current coordinates, and then as it moves we can update and we can do some loops to actually correct for the directions using the GPS module combined with other sensor data. So let's get right into it. So before I show you the software component, I want to discuss a little bit the wiring. So we have, because this LCD does not have an I2C or ISP communication like an OLED display or other kind of displays. So it requires plenty of wires, and I'm gonna very quickly discuss these wires. So we have about 16 pins to connect. So the VSS is actually the ground, then the second pin VDD, which goes to plus 5 volts, and then we have the V0, and the V0 actually what controls the brightness of the display, or more, not the brightness but rather the how to say it, the contrast of the display, which is wired to a potentiometer here, and we have the potentiometer, two ends are wired to plus and zero ground, and then we the reset is wired to pin number 10 on the Arduino board, and then we have the right RW is hooked to the ground, and then enable is hooked to 11. This wiring is actually does come with the example sketches in Arduino. I will show, if I remember, I will show in the software part where you can get some examples to start with the displays wiring. Then basically what remains is we have these D4 to D7 wires that are connected to pins 3 up to 5. And then the pin number 16 is to the ground, and pin 15 is actually what controls the brightness of the back light. So if I hooked it to 5 volt with a resistance of 230 ohm. So you can see here, if I actually pull it out, you'll see that there is data, but it's you can't see it because the backlight is turned off. And then I added another potentiometer, which I mean, again, the potentiometer, the two leads are hooked to plus 5 volt and the ground, and then the middle one is to pin analog 0, and that's so that I can use it to control the speed of the scroll of the data, which I wrote a function for that, and I will discuss that in the software. Now what remains is the GPS module wiring. So the GPS module has 4 wires, and it uses I2C protocol. So we can see we have transmit and receive which are connected on pin 12 and 13 respectively, and that's pretty much it for the wiring. Now let's get to the software. In the software I basically have two items to include. First, let me actually zoom a little bit to make it more readable. So we have the LiquidCrystal library that we use for initiating a object LCD using the LiquidCrystal structure or struct, or maybe I don't know if it is a struct C or if it is a C++ class. In any way, so it is living in this file, and then we included also the tiny GPS library, and for that we need also the software serial, and that is so that we can actually use I2C is implemented in this guy. And then we have some pins that we define, global pins, like I was discussing in the wiring. So we have an analog scroll pin hooked at analog pin 0 of the Arduino board, and then the RX pin of the GPS is hooked to 12, and the TX pin is hooked to 13. Then we define a GPS object as a global variable, as well as the software serial for communicating to the GPS, which is attached to these two pins. And then we have also the LCD, which we define all of its pins that we are using on the board here. And then we go into the setup and we basically initiate the software serial for communicating with the GPS, and then we also initialize the LCD to 16 characters, 16 columns, characters, and 2 rows. That's why it's called LCD 1602. And then this is just for debugging. I actually forgot it here, didn't comment it, because I only use it for debugging. This is to show on the serial monitor on the PC and what the data in the middle. If I have some doubt somewhere, I basically output it from the Arduino into the PC using the USB cable to check what kind of data I'm receiving and whether that's a valid data or if there is any kind of bug I have to fix. Then we go inside the loop. This is where the main code lives, and here we basically start by this is just a flag that I use for new data to make sure that the data is valid. If the data is valid, then we start basically displaying it. Otherwise we don't do anything. So we first basically spend about 1 second in each reading. So we get here, and this is where we read the raw, how to say it, the raw GPS data is collected here from that software serial through the read, and then we check for whether this is valid using the encode GPS encode function. If it returns true, then we basically have a new data. If it doesn't return it true, it means basically there is some problem with the GPS. So if it is true, then what happens? We basically define the data that we will extract. We have a latitude, longitude, and altitude, and this is just some data that is useless. And then we have the date and time, which we also extract from the GPS module data, the dump. and then we start basically grabbing these data once at a time from that GPS object. And this is all of this is actually provided by that GPS library. We then compute, so we get also the speed here. It has a function that can give us the speed in kilometer per hour. We can determine the time. The time here I'm fixing the time to my local time because it uses the Greenwich time. And then this is extracting date and time. The age, like I said, doesn't have any meaning. And then we have the satellite, the number of satellites connected. This GPS module is connected to. And then here we start printing to the LCD. There is a print function to the LCD which prints the characters. And then I delay it for 1.5 seconds. After that, basically I'm starting to stream all of the data that was collected to strings, which I'm going to scroll on the display, because our display is only 16 characters in length and has a width of 2 characters, which means it can use 2 lines of 16 characters. So string 1 will be the first line that we will scroll, and string 2 is the second. And then I defined print to LCD function, which does that, just that scrolling. And then we have a delay here of 1 second after we finish reading one data. Then we clear the LCD so that we start a new reading. And then the loop repeats, and basically we get back to right here where we start printing new data. And then acquisition, here the acquisition of the data from the GPS, and here basically the processing, or more like the preparing the data for display. And then this function does the display. This is the function that I've written, which scrolls the data from 2 strings. It takes the strings and their length, and then it determines from there basically how to scroll. And so, I mean, I wouldn't want to bore you with the detail of this algorithm, but it's quite simple. So here, so what I do is I basically scroll over the string 1 and 2, compare their lengths, and whichever is the greatest I use to compare and scroll. And basically all I do is I take 16 characters from the strings, the first, and then I keep basically looping on the strings until I get to the end of the string. And that's depending which one. I scroll up to the longest of both strings. And then once that is done, so all of this is checking and doing all the necessary stuff to scroll like that. And here I this is a lambda expression. So I compare if the string is actually less than 16 characters, then I have to change this so that we can actually display it. And then every time we finish displaying 16 characters on the screen, on the LCD, we delay it for a certain amount of time before we scroll it to the left. And the delay time is defined right here. So I use that potentiometer that I described in the wiring and read the analog values, which are using basically 2-byte analog to digital converter. We get the value which will be ranged between 0 and 1023 and this range basically varies from 0 to 5 volt. And then I basically use as delays the min is 2 millisecond and the maximum is 500 millisecond. And then this is just the map function to map the values from these two ranges, so that I get a value between these two values as I vary from extreme to extreme the potentiometer on the board. With that said, let's get to the demonstration, and actually we will take it outside using a battery. And that's it for the software portion. So just here you can see it's working inside using the USB. And these are actually the wires for wiring through a battery, the external battery. So right now it's displaying my current coordinates in data, and the blinking light is indicating that the GPS module has been connected to satellites. And just very quickly demonstration. So you can see this controls the brightness as I described, and this guy, if we actually get the brightness to the right value so I can show, and this guy controls the speed of display or scroll, sorry. So you can see here I'm gonna slow it down to half a second now. You see how it moves much slower. And now I'm gonna go all the way to 200 milliseconds and see how fast now it becomes. See how fast it is now. And if I go all the way back, now I slow it down. And that's pretty much it. So we'll take it outside. So I wanted to show you how this will work. So I'm going to take a ride on my car, and we will see that the GPS module with Arduino will be able to report the speed. Right now the speed is almost zero, it's 0.037. The date, you can see all of the data is actually extracted from the GPS module. It's the Neo M6, I think, if I can get the camera to focus. This is the module Neo 6M, and that's a patch antenna. And I hooked it to a LiPo battery, only on 2 cells, which produce about 8 volts when it's fully charged. And as you can see, Arduino, after programming it on the PC, now we can take it outside and see how it goes. So right now it's reporting basically my GPS coordinates. Wait for the new data to, so we have 9 satellites, and we have latitude of 41, longitude of -73, which means I'm on the west, and altitude of 49 meters above the sea level. And it's reporting a speed of 0 km/6 per hour, which is actually not accurate enough. The date is 6th of May 2020, and the hour is 17. So the date is 6/05/20, and the time is 17:37. Take it for a ride. We're gonna cruise at a constant speed and see if the speed matches what my speedometer is reading. See how accurate the speed will be. It's reading 22 kilometers. I don't exactly what the speed of my car right now. So we should lose some altitude because I live on a hill. The altitude is not very accurate right now. I don't know why. Sometimes it reads 41 meters. So let's see here. I'm gonna try to maintain the speed of 40 kilometers per hour. And see if we get that. Dropped the speed. Exactly. So that's, if you see the inside, which shows kilometers, you'll see it's almost above 40 kilometers per hour. Of course, I mean, this is a GPS calculation, so it's not perfectly accurate, but it's really right there. So this thing works. We're gonna pull over in a parking lot so we can show more parameters. So I've set two potentiometers. One is for the brightness of the LED, not the backlight, but more like the contrast, and the other is for the second one is for the speed of the scroll. I've written my own function, which we've discussed it before in the software portion. So you can see here I'm gonna speed the reading, so now it's reading much faster the data. You can see that now it's scrolling faster, and I can actually slow it down if I want. I can slow it down so that it moves one character half a second, the minimum, and then 200 milliseconds the fastest speed. These are constants that I set them in the code. Of course I can set it to any value I want. And then this is the brightness, the actual data.